Dear colleagues, your attention is invited to a research paper on the topic, Investigation of the Influence of Lime Content in the Charge and its Quality on the Sintering Process of Iron Ore Raw Materials. The work was carried out by scientific and pedagogical workers of the Department of Ferrous Metallurgy and Foundry Production of Kryvyi Rih National University. General description of work. The main objectives of the work were to study the effect of the degree of burning of lime contained in the charge on the sintering process and the quality of the sinter, as well as to compare the effect of changing the mass fraction of active calcium oxide in the charge on the sintering performance. 1. With different degrees of lime roasting and the same lime content in the charge. 2. With different lime content in the charge and the same degree of lime roasting. It is shown that the intensifying effect of lime on the sintering process is determined by the amount of active components introduced by lime into the sinter charge, and, at a constant proportion of active components in the charge, does not depend on the degree of lime roasting. A new approach to the production of lime for sintering processes has been proposed. It should have the lowest cost per unit of active calcium oxide contained in it. Research method. The studies were carried out in laboratory conditions in relation to the composition of the charge of the ArcelorMittal Kryvyi Rih sinter plant. We used quicklime with a particle size of 3 to 0 mm, of varying degrees of roasting. The chemical composition of the charge components is presented in Table 1. In total, 6 materials were used in the charge: iron ore concentrate, the sinter ore, manganese ore, limestone, 3 grades of lime with different contents of active calcium oxide, fuel and return. The conditions of the preparation of charge and the mode of its sintering during the studies were the same. In this case, the size of the pelletized charge, the duration of sintering, and the strength of the sinter were determined. Influence of the degree of lime roasting on the particle size of the pelletized charge at constant lime, given in the charge, equal to 3%. This effect is shown in figures 1 and 2. From figure 1 shows that with an increase in the degree of lime roasting, the content of small size classes, -3 and -5 mm, in the pelletized charge decreases. This result is confirmed by figure 2, which shows the effect of the degree of lime roasting on the equivalent. It can be seen from the figure that with an increase in the degree of roasting of lime, the equivalent diameter of the pelletized charge granules increases. The influence of the degree of fire of the lime, given in the charge, on the intensity of sintering. This effect is shown in figure 4. The lower curve, digital values on the left, characterizes the vertical sintering rate. With an increase in the degree of lime roasting from 5 to 96%, the vertical sintering rate increased from 14.5 to 29.7 mm per minute. The upper curve, digital values on the right, characterizes the specific productivity of the installation. With an increase in the degree of lime roasting from 5 to 96%, the unit's specific productivity increased from 0.96 to 1.87 tons per square meter per hour. Influence of the degree of roasting of lime, given in the charge, on the strength of the sinter. The dependence of test results of sinter in the drum on the lime burning degree is extreme. Figure 4, which is obviously caused by a change with the increase in the degree of calcinations of lime. The ratio between the development of processes that have the opposite effect on the strength of the sinter. The yield of the plus 5 mm class after double dumping of the sinter pie from a height of 2 meters while increasing the lime burning degree tends to decrease. Figure 5. Influence of the content of active calcium oxide in lime on the intensity of the sintering process and the strength of the sinter at a constant content of active calcium oxide in the sinter charge, 1.26%. The results of the experiments presented in Figure 6 and 7 show the constancy of the main indicators of sintering at different degrees of lime roasting, but at a constant content of active calcium oxide in the charge. Figure 6 characterizes the indicators of the intensity of the sintering process, vertical sintering speed and unit-specific productivity. And Figure 7 characterizes the strength indicators of the sinter, drum strength. Influence of the content of active calcium oxide in lime on the intensity of the sintering process and the strength of the sinter at a constant lime content in the sinter charge, 3%. Figure 8. Sintering speed. The arrow on the curve points to the left, millimeters per minute, specific productivity. The arrow on the curve points to the right, tons per square meter per hour. Figure 9. Output of class plus 5 millimeters after the drum. The arrow on the curve points to the left, percent, output of class minus half a millimeter after the drum. The arrow on the curve points to the right, percent. The main results of the experiments confirm the decisive impact of the active calcium oxide content in the sinter at a constant content in lime, Figure 8 and 9. With an increase in the active calcium oxide concentration in the sinter charge in the range of 0.71 to 1.58%, the sintering rate and specific productivity continuously increase, see Figure 8, as well as the drum test indicators decrease, see Figure 9. Conclusions. An increase in the amount of active calcium oxide introduced by lime to the charge from 0.71 to 1.58% leads to an increase in the specific productivity of the sinter plant from 0.96 to 1.87 tons per square meter per hour. The mechanism of the lime intensifying effect is associated with its positive impact on the process of charge peltization, reduction of the proportion of small fractions of 5 to 0 and 3 to 0 mm in the peltized charge, which is accompanied by an increase in the vertical sintering rate and specific productivity of the sinter plant. The efficiency of the limestone replacement by lime at sintering is defined by the quantity of active calcium oxide introduced by lime in a sinter charge, and in this sense practically does not depend on the lime burning degree or its concentration in charge. A similar pattern occurs when using lime as a binder in the production of pellets. This implies a new approach to the production of lime for peltizing processes. It is necessary to produce such lime, which has the lowest cost of active calcium oxide contained in it. The rational degree of burning is usually 60 to 70%. The report is finished. Thank you.